Hey everybody, Brian here. In my last video I introduced my Logic Drums to Anything MIDI script, and over the past couple months I've made a lot of updates so they can function as a true universal anything to anything mapper. Go from any source drum library to any target library. And you know, in doing all this work, I started thinking about an article I read a couple months ago about these scientists. They discovered a frozen worm in the Siberian permafrost. It had been frozen for 40,000 years. By the way, it was around the time Neanderthals started dying off. And they revived it and it started reproducing again. Can you imagine that? And that got me thinking, if I'm ever able to be frozen and then revive somehow 40,000 years later, and I went online, whatever online will mean at that time, to do a search on what's the current state of drum mapping, I hope I'd find that it's being done similar to the way that you can do it with my MIDI script. So let me show you the updates and how powerful this script really is.
Your world frightens and confuses me.
One obvious major addition is I've added a basic GUI, and I have to stress up front, the GUI isn't meant to have you dealing with the mapping itself. That is still specified in the script, because if you look at what's entailed in a mapping, you can see there's no reasonable way to handle all these kind of intricacies in this GUI interface. And the mapping itself you can think of as a syntax, a pretty basic one at that. So once you get used to that syntax, setting up a mapping is no more difficult than writing an email to somebody. You know, as long as you're writing that email with proper syntax and grammar and that kind of stuff. Okay, now that I explained to you that the most important part of this script, the mapping, can't be done in the GUI, let me talk about what you can do in it. So the first thing to notice is that we see this show advanced stuff, block unmapped notes. If you don't have a proper mapping, you're not going to see these entries. So first let me just open up a script. I'll add a character in one of these articulation names that's not allowed, and then run script. So now the GUI is telling us there's an error. It says list syntax error. So here we made a syntax error in this list, but the details are in the actual console output. So now we see syntax error in target articulation list, articulation name, HH close, bell with this unallowed symbol. So let me just get that back to normal and then run script. Now that error went away and we're good to go. Now there might be warnings. Usually warnings don't really mean too much. They might put your attention to something that might need attention. In this case, it's just telling us there's some articulations not being mapped to, there are some articulations that aren't being mapped, etc. And so as long as you have a validated mapping, this is what you're going to see. The show console output option, that controls some of the output that you'll see in the window here when the mapping is going on. So if we hit play, we'll see some status being displayed. And if you want to see extra detail, then you can click on Show Extra Debug Info. This is a good idea if you're setting up a mapping that I haven't done in any of the included scripts, and you really want to make sure things are going how they should. Then you can click that on, and then if you hit play, you'll see additional output. So now you see these debug lines added. Now these things take up CPU resources, so once you know you have a good mapping that's been validated, you know things are working well, then you may as well just click those off. And now if you hit play, you're not going to see any additional output. So that's what those are all about. The block unmapped notes option, this is probably recommended. I mean, if you have a source library and there's some note that didn't get mapped to the target, then that note is going to get passed through to the target library and it might produce an undesirable result. I mean, say for instance in the target library you have some note F#4 and say that's a cowbell. Now say in the source library you have an F#4 note that is some drum percussion hit, but it's not being mapped to the target. If you don't click on block unmapped notes, then that note's going to get passed through to the target library and it's going to generate that cowbell sound in the target library. Now you might not want that. You might not be interested in more cowbell. Or maybe you might be. In any case, it's just a good idea to understand what that's all about. And then show advanced stuff, if you click on that, you'll see some additional things that you can take control of. So I'll click on that. And by the way, if you don't see anything after you click on it, Logic is this weird quirk where sometimes you have to hit play, otherwise it won't do anything. But in my case, it showed up right away. So that's just important to know. If you click it, you don't see anything, just hit play, then stop immediately, and then thereafter it'll work fine. Okay, so what do we have under show advanced stuff? So one thing that's been added, and this really is one of the keys to making this work as a universal any source to any target mapper, is the option to do source to target CC translation, where you can just filter out any of the source CC data so it doesn't even get to the target library, or just pass it through as is, which That probably won't make sense in most cases, but translating is probably what you're going to want to do here, or none. All right, what is CC translation all about? So let's say we have some Superior Drummer 3 part, and it has hi-hat foot control data, as well as snare position control. What this feature will do is it'll allow that data to be translated to the target, and you don't even have to worry if one is inverted. The script will figure that out automatically so that everything looks correct in the target, and then the end result is that data, in this case, is being translated over to Addictive Drums2, and in the case of hi-hat control, one's inverted, the other isn't, but the script handles that. So in Superior Drummer 3, when you see the CC data ramping up, in Addictive Drums2 it's ramping down, so that's handled automatically. In the case of the snare control, they both have similar action there. There's no inversion, but the main thing is the values, the levels are matched from one to the other. So if we open up a script, we have the CC ranges source variable. This is where we enter the details of how the CC control is used. So in Superior Drummer 3, this is exactly how its levels are delineated for hi-hat control and snare position control. And here we see similar data, this time for Addictive Drums2. This is CC ranges target. And this ensures that a level 1 in the source library is going to be translated to level 1 in the target, which is a very precise way of doing this kind of CC translation, so that the particular level of something being open or closed, edge or center, that it's going to very accurately translate over to the target. In case you're wondering, how did I get to this end result in the first place? Well, you can record the MIDI output from the script. So you just go to track, set the internal MIDI in. So what I've done here was I told this to record from that Superior Drummer 3 track, and then you solo both, solo that one, solo this one, hit record, and that's what produced this result here. After you've done that kind of internal MIDI recording, be sure to turn the internal MIDI in off. Otherwise, really weird things can happen. You'll be playing back what you think is this Addictive Drums2 part, but it's still taking the MIDI from this track. You'll notice right away that something's off. So just be sure to always do that. And another feature is what I would call CC articulation switching, which isn't the same thing as source to target CC translation, and it's not something that the GUI deals with. So what is this all about? Let's say we have some part that originated in EZDrummer 3, which can use snare position control, which means using CC data can control whether it's a center or an edge hit, and then we're going to Logic as the target, which doesn't have that ability. So what's going on here is you can now take that CC data and it'll be translated to switch to whatever articulations are the equivalent in the target library, in this case Logic. So here we have some F sharp -2 note, and if we open up the mapping information, we see that's EZDrummer 3's snare zone trigger, and the way it uses that CC data, values between 0 and 79 in EZDrummer 3, those are center hits, and values between 80 and 127 are edge. So what we do in the mapping is we're telling it, okay, whenever we see this snare zone trigger note, look at the AID switch, which says a level of 1 should go to Logic's snare center, a level of 2 should go to Logic's edge, and this doesn't mean that you have actual AIDs. This is happening purely through the CC data. So it's going to look at CC number 16, and it's going to know that in the source, in EZDrummer 3, whenever you have these kind of values, then it's going to treat that kind of like an AID, but let's just call it a level. It'll be level 0, 1, which is going to be the center, or a level 2. And we can see that in action if we just hit play. Make sure you're seeing the console output. And so if we look at the output, you can see in some cases the snare zone trigger was resulting in a snare edge hit. In other cases, it was resulting in a snare center. And you can see what was going on in the CC data. We were just ramping up through the level 1, as we call it, to the level 2. So remember, level 1 was up to 79, and then from that point onward it was level 2, which were the edge hits. So that's why we first see the center notes being triggered, and then once we got past CC values of around 80, that's when it switched to the snare edge. So that's how that works, which is a pretty useful feature. It gives you a ton of options for using CC data to kind of act like articulation IDs and trigger articulation switching in a target library based on that. Moving through some of these other features, HH pedal settings. So one other feature I added, which is pretty cool, is the ability to do automatic pedal closed, chick, and splash detection. So you go in here, you can either do chick detection, splash, or both. So I'm I'll click on both, and you see some additional options. And what I have here is real data recorded by a human using the Roland TD17. So here's its data, and it uses a threshold of 90 for its closed, and it uses channel 10. So you choose that channel in the script, and the sensitivity is set in the middle, which is usually fine, but you can adjust that, make it more sensitive by sliding that forward, or less sensitive by sliding it backwards, independently for the chick and the splash detection. And you also choose some target note, so that in the target library, some relevant foot close or foot splash note is being triggered. And that'll be automatically set up in all the scripts that I provide as one of the parameters here, as you have these options at the end of the script set up. So there it is, put the actual name of those notes in the target library, which is why they then show up here. These are logic notes. And how does this work? Okay, so now we have it set up, ready to do its thing. And it's going to look at the timing to see if a close was done sufficiently fast as well as an open, so that it generates those pedal close and pedal splash notes in a way that makes sense given the data. And if we hit play, we'll open the script as well. Let's hit play. And then in the output, you'll see when there was a chick detected or a splash. And of course, you can record those results. So if we set it up like I showed you earlier, how to do internal MIDI recording, set that up and then hit record. And here's what that kind of recorded MIDI looks like. So you can see when it was ramping up, that corresponded to a pedal closed. And when it goes down quickly, that's a pedal splash. So we're seeing those detections represented by the actual notes that are being generated for Logic to play back. And this is a super useful feature because not all plugins do this kind of detection. Some plugins like Addictive Drums2 do it pretty well. And then the Toontrack products, I think they also have some capability, maybe not quite as robust as Addictive Drums2. Some VSTs won't do it at all. So this way you have a unified approach to doing this kind of chick and splash detection. Even if a plugin doesn't support it, the script will do that for you if you need to do that kind of thing. Another super useful feature is the ability to generate Flam, Ruff, and Roll kind of sounds in the target library, even if the target library doesn't contain those kind of articulations. So the way that works is you look at what the source library has. In this case, we're looking at Superior Drummer 3 going to Addictive Drums 2, and Superior Drummer 3 already has a snare Ruff's articulation as well as Flam's, but it doesn't have a roll articulation. So I've added the ability to manage user-defined notes through this variable UN, and it's pretty easy. You just specify any note you want to add, and if you know some unused note name, you can add that here, or you can just specify an empty string like that, and the script will automatically assign it to some unused note. And then what you do in the mapping, given that Addictive Drums 2 does not have any of those kind of sounds, flams, ruffs, or rolls, you can still trigger those sounds in Addictive Drums 2. So here's the Superior Drummer 3 snare flams, and using this new parameter flam, etc., specifying flam, that's going to use Addictive Drums 2 snare position control and just randomly playing hits varying from edge to center. And then likewise using the snare ruffs articulation from SD3, now we use that flam, etc. parameter specifying ruff. It's going to trigger edge or center kind of sounds during that ruff, and those snare positions will be randomly assigned via this AID assign parameter. And this parameter existed in the previous version of the script, and just to remind you what that does is because I've specified these three kind of levels between center, center edge, and edge-ish sounds, that just ensures that Addictive Drums 2 will apply that kind of position control randomly. And then here's the snare roll note that we invented. In a similar situation, we use that flam, etc. parameter. This time we specify roll. Those are the three options, flam, ruff, or roll. And the result of that is we can hear those kind of sounds in Addictive Drums 2. And in the GUI, you can control some aspects of that generation. In the case of rolls, you can adjust the timing and velocity variation so that there's some humanness, if you wish. And then with flams and ruffs, you can adjust the speed. Those tend to be just 2 or 3 hits, so there's not much to adjust. Just adjusting the speed is good enough to control the sound of those kind of hits. Here's what happens if you slow down the roll and add some timing variation. They'll still be slow, it's just that the timing will be adjusted a little bit randomly. And you can adjust the velocity variation as well. So here's what that would sound like. Or you could make them super fast. That's kind of crazy. And if you click on user snare notes, this will tell you which notes you specified to be managed. Remember we added that snare roll note because Superior Drummer does not have that. Because there are so many articulations used by Superior Drummer, it doesn't leave much room left over for user-assigned notes. In fact, there are only 2 available notes. The snare roll is this F-2, and we see this message here telling us that there aren't even enough available notes to make any kind of changes. Now we see this C-2 here, but that's actually another user-assigned note, and if we try to change the snare roll to the C-2, we're going to have our attention brought to the fact that that's already being used. Now usually you'll see a drop-down menu here with a whole bunch of notes you could choose, but Superior Drummer is obviously a pretty unique case. Let's look at another example of using this feature. So this time we're going to go from Logic to Slate Drums 5, and if we look at the mapping information there, because Logic doesn't have any of those kind of notes, we've specified them all under snare. So we have the snare flam, ruff, roll, and I've also added a snare MIDI roll, and I'll explain why in a second. Now we're looking at Slate Drums 5. Notice how it actually has a snare rolls articulation. But the thing is, it's not a roll in the way you'd expect. You know, if you write out a long note, it's not going to result in a long duration roll. So what we're doing in the mapping is we're going to have this user-defined snare flam trigger a flam with some MIDI trickery. Same thing with the ruff. And then with this snare roll articulation, we're not going to use the flam etc. parameter because we're going to trigger the actual snare rolls articulation in SSD5. But in case you prefer to actually do it artificially, that's what this note here is for. And now we're using the flam etc. parameter specifying roll. And so we'll give those a listen to. So notice the Slate 5 roll, even though the note here is elongated, the roll was very quick, just a few notes in the beginning. And so now we're going to hear what it sounds like when we generate the roll artificially using the trickery method. So once again, this is Slate's own roll sound. And if we want to actually generate that kind of sound where the roll will be the duration of the note, and that's what that'll sound like. So that just gives you flexibility to control how those kind of sounds are generated, either artificially or using an existing articulation in the target library. The next feature in the GUI to talk about is the cymbal settings. So this is mainly dealing with choking cymbals, which is a pretty contentious topic. Most people tend to have a lot of complaints about how that works and is not consistent between libraries. So I've added the ability to control how choking is done as a handoff from a source library to a target library. So first we're going to talk about translating a choke note from a source library to a target library. In this case we're dealing with Logic going to EZDrummer 3. And if we open up the script, for instance, here's how we're mapping a Logic cymbal left crash over to EZDrummer 3. And we're also mapping Logic's cymbal left choke, which it calls crash left stop. And the way the script is set up initially, it's telling it to use Aftertouch, channel Aftertouch, to do that choking in EZDrummer 3. This set vel parameter, that's only going to apply when we use a different method. I'll talk about that in a second. The main thing is that in a given script, this kind of data is already set up, at least in all the scripts that I've provided. And then after the fact, you can make some changes via the GUI. So let's go back to the GUI. And here we see target chan Aftertouch. That's based on what the script sees as already being set up. But for now, let's just put that to none. Put them all to none. I'm just going to talk about this one for now. And if we choose none, then nothing is going to happen with this Logic choke note. It's just going to be filtered out and we'll hear the cymbal without any choking. Now if you hit pass through, that's going to pass on the logic choke note, map it to that equivalent choke note in EZDrummer 3. So even though in the script we didn't specify it to use an actual choke note, we told it use channel aftertouch, here we've made a change that's going to control how this happens. So now we hit play, and you heard the cymbal was choked properly. That generated an actual choke note in EZDrummer 3. Now here's the thing about pass-through. Pass-through is not using any of the choke-specific mapping info. It's just going to map it like any other note. And in this case, because a logic cymbal left crash, in the target can be crash 1 or crash 2. That's how I set up the mapping, because EZDrummer 3 has crash 1 and 2 towards the left in the stereo field. And similar with the choke note, it's mapping to either the crash 1 choke note in EZDrummer 3 or the crash 2. So sometimes there'll be no choking, because if a crash 1 note was chosen in the mapping, then the choke note was, say, crash 2. Well, EZDrummer 3's crash 2 choke hit is not going to choke a crash 1 hit. So if you want choking to work properly, you have to pay attention to these kind of nuances. So now let's progress through these other options. Now I'm going to choose target channel aftertouch. That means this logic note is going to generate channel aftertouch in EZDrummer 3. It's not going to result in a choke note being played. The choking happens through aftertouch. So if we hit play, the choke was kind of subtle, because in EZDrummer 3, when you have aftertouch doing choking, the length of the choke is the length of the aftertouch message. In this case, what the script is doing is it's saying send aftertouch data starting at this point and then ending at this point. So if we shorten the input note and hit play, now notice the choke was quicker. Make it longer, the choke is longer. And then we can also choose poly aftertouch. That's also supported in EZDrummer 3, and that's going to work the same exact way. And now let's choose a target choke note. And the way EZDrummer 3 handles a choke note for choking is it's going to be the same kind of sound no matter how long the input note is, no matter how long the choke note is. So the library that has the kind of functionality of EZDrummer 3, and by the way, Superior Drummer 3 is similar in how it handles choking, it's better to have aftertouch being applied. And then we can record the result. For instance, if we have one of the aftertouch methods being used, record that. Okay, we heard that weird piano kind of sound. That's because I didn't have an instrument set here. Don't worry about that. The important thing is to see the recording, which now contains aftertouch data coinciding with where choke note was. So here we're looking at where that choke note in Logic started, and then the recorded result in EZDrummer 3. Here is where the aftertouch message is starting. So it sends a 0 when that choke starts, and then where it ends is where a value of 127 is sent, and then it ramps back down afterwards. And that's how EZDrummer 3 uses aftertouch to choke a cymbal over a given duration. We could do likewise with poly aftertouch and record that result as well. And here we won't see anything regarding poly aftertouch. The way to see this kind of data is click on that region that resulted from the recording, go to Window, open Event List, and now notice these P entries. If we go back to the source choke note, that note started here, and then in the recording, now notice that the poly aftertouch message, it starts when the choke starts, sending a value of 0, and then when that choke message ends, there's a value of 127 sent, and then a ramp down back to 0. So that's how that works. There might be cases where you have aftertouch being used in the source to do the choking, in which case it's not producing a choke note. So in order to handle choking in that kind of situation, we need to be able to translate source aftertouch data to the target library. Similar to what we just talked about in how to translate an actual choke note, everything applies in this case as well. So here's an actual real recording done with a TD17 that a user on the VI control forum provided me. This is him playing some ride hits and choking with the aftertouch data, in this case poly aftertouch data, generated and recorded. And in order for this to translate choking, we have to tend to these settings. If we use none, then if we play back, there's no choking going on. So what we do here is under Translate Poly Aftertouch, because with TD17, that's what we have. So if we look at what's going on in the event list, there's a whole bunch of these P entries. That's the actual Poly Aftertouch data that exists here. and that's what we need to translate. So first we chose none, we didn't hear any choking. If we use pass-through, that's also not going to work because the source note isn't the same as the target note. In TD17, these ride hits have certain notes, but in this case, Addictive Drums2, which is the target, its ride articulations are on different notes. So the way Poly Aftertouch works is the Aftertouch data has to have the pitch data as well. So now let's choose target Poly Aftertouch and hit play. So now we hear the choking happening in Addictive Drums2, and let's see what happens if we chose Channel Aftertouch, which doesn't require any pitch data. We'll stop that because I know that's not going to work in Addictive Drums2 because Addictive Drums2, for whatever reason, does not support Channel Aftertouch. It only supports Poly Aftertouch or a choke note. So we can have it play back a choke note. Though in this case, if the source library is generating Poly Aftertouch and the target library also supports that, that's obviously the best choice for choking. But just to see what happens if we do choose a target choke note. So it works, but like I said, the desirable situation here is choose Poly Aftertouch because Addictive Drums2 supports that. We'll do another example on choking, this time using Logic, mapping to EZDrummer 3. And in this case, what I've done is I've added a ride choke articulation. Logic does not have that natively, but we can use the nifty user-defined notes functionality of the script. Add it, give it a name, or let the script automatically figure out an unused note to use. In this case, I've specified C-1. And in Logic, the, say, ride edge hit is E2. This would work with any ride articulation. And then with that user ride choke note defined, going down to the mapping, here are the Logic ride notes being mapped to EZDrummer ride notes. And then the Logic ride choke note that we invented, that's going to target the actual ride muted hit in EZDrummer 3. The chokes parameter says this choke note here chokes these notes here. And then I'll talk about this set val in a second. And this :AT, that means that it's going to be using the channel aftertouch method by default, but we're going to change that via the GUI to run through the various possibilities. So here we are in the GUI under cymbal settings, and I've clicked on user cymbal note, so we see what's available here. There's that ride choke note. And if we don't do anything regarding choking, that's just going to play back that ride edge hit with no choking. And first, let's look at what happens if we have a choke note and choose channel aftertouch. That choked in EZDrummer 3. Likewise, we can use Poly Aftertouch or a choke note. And I'm just noticing that in EZDrummer 3, its aftertouch choking doesn't seem to produce the kind of really quick choke that a choke note produces. With aftertouch, this seems to be the quickest duration. Extend that out. It's still a choke, just with a longer duration. Anyway, that's nothing new. We saw that a moment ago when we were going through a choking example. And now, what I also have here is Poly Aftertouch. So I'm going to click here to view the automation data. And here's the source Aftertouch data now. So even though Logic doesn't use Aftertouch for choking, I just drew this in here. So we have Logic producing Aftertouch data, and that's channel Aftertouch. So now we're going to have that go to EZDrummer 3 via channel Aftertouch. Because I chose none for the translate choke note, this choke note won't do anything. We could mute that if we wanted to. But in any case, let's just hit play. And you heard that choke action. Same thing if we choose Poly Aftertouch in the target. So now in this case, channel Aftertouch was generated on the Logic side and then sent over to EZDrummer 3 as Poly Aftertouch data. And of course, we can also choose a choke as the target note. So now the Aftertouch data from Logic is going to trigger an actual choke note in EZDrummer 3. Finally, I'm going to talk about this set val parameter. So in terms of choking, what this parameter does is it says, okay, if this is an input note that's supposed to be choked and the choke method is going to be a choke note in the target, then set the velocity between 1 and 34. In this case, when the script was initially set up to have the target use channel aftertouch, set val would be ignored. but because we can control that in the GUI, I'll show you how this is used. So we'll keep this as is, but for now I'm just going to comment out that parameter. Now hit play. So what we're doing here is the channel Aftertouch message here is going to trigger a choke note in EZDrummer 3. If you listen carefully enough, you'll hear there are two attack sounds from the cymbal itself and the choke note. Now let's go back to the script, uncomment that. Now hit play. Notice how you no longer hear that attack. Libraries work this way where their choke note is like a one-off hit. They tend to vary on as far as what velocity is kind of the cutoff point to not hearing that attack component of the sound any longer. And in an EZDrummer 3 and Superior Drummer 3, that just so happens to be around 34 or so. So something to be aware of, and that's automatically set up in all the scripts that I provided. Any library that acts that way, it uses that set vel parameter so that you can do choking and not hear that additional attack sound. And while we're here, notice we can change that ride choke note. So right now it's C-1. We could change that to say D-1 right from the GUI. So we move that note up to D-1 and it'll still work. And if you want to go back to how things were, you can always hit reset to defaults. And now everything is set up as it was prior to making any GUI changes. Now I see the ride choke is returned to C-1. So that's a useful button to know about when you want to get back to where things were before all your experimenting. So there, that was a lot on choking, but that's because choking is a pretty tricky subject. In order for you to maximize the possibility of choking happening the way you want it to happen between the source and the target, you really need to understand the nuances of how these settings work. Finally, I'm going to talk about this set vel parameter. So you saw how to use that set vel parameter to make choking work as you might want it to. Now we're going to talk about another use, and actually the main reason I decided to add this parameter is because of libraries like Get Good Drums. So here I have Get Good Drums on a track, and I'm using the Logic Drums to Get Good Drums script, and I'm going to open that up so I can show you what's going on. For whatever weird design reasons, Get Good Drums decided that for velocities above a certain level, One Hit Wonder Architect's kit happens to be above 79, it's going to trigger a snare rim shot as opposed to a center. So anything under 80 is going to be a center. So that's why you're seeing these set vel entries here. What's going to happen is, say in a library like Logic, in order for an edge hit or center hit in Logic to be guaranteed to not play back as, say, a rim shot in Get Good Drums, you have to force the velocity to be between 0 and 79. And likewise, if you want a Logic rim shot hit to trigger a rim shot in Get Good Drums, you have to force the velocity to be 80 to 127. So let's hear that in action. First I'm going to comment these out. So you see what happens if we don't use that parameter. Here's some MIDI part that has a combination of snare, regular, and snare rim shot hits. Now you're probably noticing that only in a couple of rare cases did you actually hear a rim shot, and that was happening when the snare note just happened to be in Logic already at a velocity above 79. But there were other rim shot hits as well. And to get those to play back truly as rim shots, I'll undo what I did here, get those parameters back in play. And now let's play it back. And that obviously sounds much better. So now these Logic rim shots are truly playing back in Get Good Drums as rim shots. And you'll see output to that effect in the console if you have show console output checked. So if we play that back again, you'll notice these messages, such as this note requires setting velocity to map properly in target library, set the velocity. Okay, so that was all about how to get some source library to properly play back snare hits in Get Good Drums. Now what about the case when Get Good Drums is the source library? So now we're going to look at that case. In this case we're going from Get Good Drums to EZDrummer 3. Notice now I'm using a parameter called vel switch. This is something else I added in the new release of the script. So what this does is it says, okay, say I have that Get Good Drums snare hit, and I want to be able to have it trigger regular snare hits versus rimshot hits in the target library. Well, the only way for that to happen is for the mapping to know what to do when it sees certain velocities from the source. So in this case, what it's doing is it says, okay, if I see a velocity between 0 and 79, then trigger an EZDrummer 3 or snare center or snare edge hit. If instead the velocity is above 79, then trigger the rim shot. So this is velocity-based switching. Earlier you saw AID-based switching, CC data-based switching, now we're looking at velocity switching. And if we disable this and play this track, we're not hearing rim shots being played back in EZDrummer 3 because without this parameter, there's no way for that to happen. So I'm going to uncomment this and we'll play that back again. And you'll agree that's obviously a much better rendering of the hits in EZDrummer 3 because we're now using that velocity switch. Now I want to show you something cool you can use the script for to liven up drums, especially hi-hats. So there are a lot of MIDI files available online to download. Some of them are advertised as recorded by a real human, but they're often in this general GM format. So here what we have is an F#1, that's your typical hi-hat closed sound, and then here A#1, that's the open sound. And in this case, I'm looking at Slate Drums2 as the playback. So if you have this kind of MIDI, it's not going to be able to do anything interesting in the third-party library because that library is only going to see these hi-hat closed or hi-hat open notes. And so during playback, you're going to have this very static kind of sound. You're going to have one kind of closed sound and one kind of open sound because there's no foot control CC data to tell the plugin what to do, to give it some life and have it be several open levels or one of several closed levels. So with the script, you can actually force that kind of behavior, which is kind of cool. So let's play this back so you can see what would typically happen. I muted most of the other parts so you can really hear the hi-hats, and it's pretty static sounding. One type of closed sound, one type of open sound. So now let me show you what you can do to liven that up a bit. So in Slate Drums2, the F#1 note would map to this HH tip CC, and the A#1 note, the open hi-hat sound, we could map that to say the HH shank CC. So what we're going to do is use AID assign and the CC num parameters, and I'll explain what that's all about. So how does this work? Now, anytime there's an F#1 in this MIDI here, it's going to trigger in Slate Drums the HH tip CC. It's going to randomly assign either 1, 2, or 3 as the level, and those are all closed levels. So we've specified CC num 4. So how does this actually work? So if we look at Slate Drums CC settings for the hi-hat control, CC number 4, here's how Slate Drums does its hi-hat control. It has 1, 2, 3, 4, 5, 6 levels, and then we write out 7 levels. The script already has this set up. We use that baseline number of 7 levels for hi-hat control between various drum libraries. So if the mapping says, let's assign level 1, 2, or 3 randomly, then basically that's going to be choosing closed-ish kind of sounds in Slate Drums. And if 1 is chosen, then a CC value between 110 and 127 will be generated, and likewise these other values in these other ranges for the other levels. So that's how that works. That's how we assign an AID, even though we're not really using it as an AID in the way Logic does. We're just considering these as generic levels, level 1 through 7. And then likewise, when we assign levels 4 through 7 randomly, depending on what level is assigned, it's going to look at the range of CC values and generate that CC value and send that over to Slate Drums. So now these HH triggers in Slate Drums, they're going to do their thing because they're receiving the correct CC data that's going to result in them knowing which level to play back. So we can actually see that in action. Let's hit play. Now the difference is subtle, but subtlety in music production is not a bad thing. So So taking this very static hi-hat sound and making it a little bit more dynamic. So here we see in the output of the script that these various AIDs are being assigned, and then corresponding CC data is being generated, and that's what enables on the target side to actually play back those hi-hat notes with some life. So that was the overview of the new version of this script and all the things that it can do to help achieve true universal any source library to any target library mapping. And with that said, let me show you a couple of these sorts of mappings. So let's say you want to go from EZDrummer 3 to a simple library like GetGoodDrums3. Here I'm just setting up the CC ranges source and target to correspond to, on the source side, EZDrummer 3, on the target side, GetGoodDrums3. And it's easy to do that. I can just copy and paste from the various logic to some library scripts, because I have logic to EZDrummer 3, logic to GetGoodDrums3. So it's a matter of just extracting from those scripts what you need for these kind of mappings. And then likewise, the source articulation notes. In this case, here are all the notes in EZDrummer 3, and then likewise, all the notes in GetGoodDrums3, and then any user-defined notes that make sense for the mapping, and then the mapping itself. And in this video, I'm not going to get into all these details. The video is long enough. I'll have a separate video showing you step-by-step how to do this kind of mapping. And then with that done, if you have some MIDI part that was for EZDrummer 3, and you want to play back and GetGoodDrums3, maximizing all the functionality in both, well, that's easy enough to do with these anything to anything mappings. Okay, that's probably a boring drum part, but you get the idea. Let's say we wanted to look at a more complex mapping, same thing. Here's period drummer 3 to Addictive Drums2. Concept is exactly the same. I'm just setting up the CC ranges source and target variables as needed for this mapping, which is just a copy and paste from the logic to SD3 and logic to 82 scripts. And then here are all the period drummer 3 notes, about 125 of them. And then likewise all the Addictive Drums notes. And the mapping, which is pretty significant, but it gets the job done. And conceptually, it's no different from any other mapping because of the consistency in this mapping language that I've set up. And so you can easily go from a superior drummer 3 part to an Addictive Drums 2 part. And because we already talked about CC translation, you can appreciate how doing these kind of mappings preserves that kind of data. So this is truly the most robust way to do drum mapping from a given source to some target library. I'm not aware of any product out there that handles these kind of mappings with this level of thoroughness. And one other thing you can do, let's say you want to do a quick test. I have some parts that came from TD17, and let's say I want to hear how that sounds in Slate Drums 5. Now, I haven't done a TD17 to Slate Drums 5 mapping, but I do have TD17 to Logic, so I can chain these scripts together. So the first script, that's going to go from TD17 to Logic, and then the second one is going to go from Logic to SSD5. And that would be a quick way to preview how that would sound in some other target library. Okay, so that concludes the video on my very non-caveman approach to drum mapping, and hopefully you see the power in this script and how you can use it for any imaginable drum mapping scenario. And if anything's unclear, just comment and I'll get back to you. Thanks for watching. Until next time.
It's just key rock, Your Honor, and yes, I'm ready. Thank you. Ladies and gentlemen of the jury, I'm just a caveman.